Hello students, this video is about or based on the topic test that we have on the Bodhee Prep app for you. The basic idea of these tests are you prepare a concept, you practice the concept, and then you can take this test to understand whether that concept for you is exam ready or not. Once you have taken a test, you look at the video attached with the test. In the video, we give you the solutions and a basic analysis of what could have been a good attempt in terms of number of questions, level of difficulty, and the time. There are more than 200 such topic tests and analysis videos available on the Bodhee Prep Android app. The link for the app is in the description of the video. So feel free to download the app and make use of these tests. In this video, we talk about the subtopic factorial cyclicity based system based tests. And this is test number 2 in the app. Overall, the test was moderate level of difficulty and about 6 to 7 questions correct would be a good attempt in terms of a 95 or plus percentile. In terms of time, I think 18 to 21 minutes should be the ideal time to attempt all the questions and in a way that you get about 6 to 7 net questions correct. If you look at the questions, question 1 says, find the highest power of 30. 30 is 2 into 3 into 5. Now, clearly, if you look at 2 into 3 into 5, the limiting power will be 5 because it is the largest number. So basically, we just look at the highest power of 5 that divides 50 factorial. That will be the highest power of 30 as well because that many 2's and 3's will always be present. Now, if we look at the highest power of 5 dividing 50 factorial, all we have to do is divide 50 by 5 and then divide 10 by 5 because we get 10 here. Add these two numbers, so 12. So 50 factorial can be factorized in a way that the highest power of 5 here is 12. And therefore, when we divide this by 30, 30 can take up a power that is up to 12. And therefore, 12 becomes my answer because if you look at powers of 2, 3, and 5 in 50 factorial, clearly 5 will have the lowest power and that is 12. And therefore, 30 can have a maximum power of the limiting number. Answer 12 for this question. Now, in terms of level of difficulty, it is an easy question. The fact that you've done factorials should mean that or highest power of a prime dividing a factorial. This is the standard process that we follow for a question like this. It should be done in the examination and definitely less than 2 minutes to solve this question. Find the highest power of 72. 72 is 8 into 9, which is 2 cube into 3 squared. Now what we do is we look at the power of 2 in 100 factorial. So we start dividing 100 by 2 successively and taking the greatest integer functions. 100 by 2 is 50, 50 by 2 is 25, 25 by 2 greatest integer function is 12, 12 by 2 is 6, 6 by 2 is 3, 3 by 2 greatest integer function is 1. Further division cannot happen. We add all of these powers. 50 plus 25 is 75, 87, 87 and 10 is 97. Therefore, if you look at 100 factorial, it has 2 raised to power 97 into, now we look at 3 power of 3. Power of 3 in 100 factorial will be 100 upon 3, which is 33. 33 upon 3, which is 11. 11 upon 3, which is 3. 3 3 are 9. 3 upon 3, which is 1. So 44 and 4, 48. Into other numbers, which comprise of 5, 7, 11, 13, and so on. Now, if I'm dividing 100 factorial by a power of 72, say the power is x, 100 factorial is 2 raised to power 97 into 3 raised to power 48 into something. 72 is 2 cube into 3 square. So what we do is we take out 2 cubes and 3 squares from here. If we divide 97 by 3, 96 is divisible, 96 by 3 is 32. This can be written as 2 into 2 cube raised to power 32. 96 plus 1, 97. We need 3 square. So 3 square raised to power 24. 2 cube into x, 3 square into x. Now the question is, what is the maximum value x can take? Now, if you look at the limiting value for 2 cube or 3 square, there are 32 2 cubes available and 24 3 squares available. So obviously this is the limiting value. If x takes any value beyond 24, we will not have enough 3 squares to be divided. And therefore, the highest power of 72 that divides 100 factorial is the highest power of 3 square that divides 100 factorial, which comes out to 24 becomes the answer. Again, the process is the same for every question of this type. Just because of the calculation, I'm saying moderate. There are chances of a silly mistake happening, and therefore moderate. Otherwise, a question that should be done in the exam. Convert the number 1982 from base 10 to base 12. We know that the answer will have 4 digits because uh, that is how many digits each of the numbers has. This will be 12 raised to power 0 or 1. This will be multiplied by 12. This will be multiplied by 12 squared, which is 144. This will be multiplied by 12 cube, which is 1728. Now, what is the maximum number that can come here? We are trying to convert 1982 in base 10 to a base 12 number. Clearly, 1728 will divide 1982 only once, so I write 1 here and subtract 1728 from here. So we get 54 and 254. If I look at 144, again it is divisible once. So I subtract 144 from 244. We are left with 110. If we look at 12, 12 divides 110 9 times, which is 108. We are left with 2 and therefore 2 in the end. Hence the value will simply be 1192. I take the highest power of the number and start subtracting that from the given number until we reach a phase where nothing is left. So 1982 in decimal will be equal to 1192 in the 12 base system. We could have also followed the standard process where we start dividing 1982 by 12 and you get the remainders and then simply take the remainders in the reverse order. I'm just saying it will be a longer process and therefore I did not do it. But if we do follow that process, then what happens? 1982, 12 ones are 12, 7 8 6 are 72, 6 2 5 are 60, so 2 remainder. Then again 12, 165 by 12 will be 12 ones are 12, 4 5 3s are 36, remainder 9, 45, 12 ones are 12, remainder 1, and therefore the number will be 1192. Whichever you think is the more intuitive method, we can follow that method. But the point is, both of these methods are standard methods for converting bases, and therefore overall, if I talk of the level of difficulty, this will remain an easy question. Should be attempted not more than 2 minutes to solve the question. How many natural numbers n are there such that n factorial ends with 30 zeros? When we're looking at natural numbers and n factorial ending with 0, basically we're looking at the highest power of 10, which divides n factorial. Also, since 10 is 5 into 2, always n factorial will have more 5s than 2s. If you're looking at n as a natural number and n factorial. So we just check for 5. We'll take values of n to see how many 5s are there in an n factorial. Suppose n is 100. 100 factorial, if you look at the highest power of 5 dividing 100 factorial, standard process, this will be 24. The number here was 30, so I need to increase 5 6 times over. Fifth multiple of 5 is 125. I'm just looking at powers of 5 as long as possible, or multiples of powers of 5. I check for 125. 125 by 5 is 25. So where n factorial is 125 factorial essentially. 125 by 5 is 25. 25 by 5 is 5. 5 by 5 is 1. Now, if we look at it, the total becomes 31. So 125 factorial has 31 zeros, trailing zeros. But a number before this, that is 124 factorial, if we look at it, 125 has 3 5s. 124 factorial into 125. So this will have 3 zeros less. We can also check 124 by 5 is 24. 24 by 5. Reducing the function, this is 4. 24 plus 4 is 28. Now, any number less than this will have 28 or lesser zeros. Any number more than this will have 31 or more zeros. So how many numbers end in exactly 30 zeros? There is no number that ends exactly in 30 zeros. Now, this concept is something that is probably moderate to difficult to understand. But once you know the concept, the question is not very difficult. 2.5 minutes, good enough to answer the question. two different two-digit natural numbers are written beside each other such that the large number is written on the left. Suppose the two numbers are A, B and C, D, where A, B is greater than C, D. We get a when the absolute difference of the two numbers subtract the four-digit number will be A, B, C, D, A, B, C, D, and from this we are subtracting the absolute difference. So the sign is not important. When the absolute difference AB minus CD. Clearly, AB minus CD will be the positive value because AB is larger than CD according to the question. When this difference is subtracted from ABCD, the number obtained is 5481. So what we can do is we can write the decimal equivalent of these numbers to start the question. Now this is a four-digit number, so this will be 1000A plus 100B plus 10C plus D minus, here we'll have 10A plus B minus 10C minus D. Because this number is being subtracted, this is given as 5481. Opening the bracket, 100A minus 10 is 990A. 100B plus 10B minus B is 99B, 990A, 990A plus 990B plus 10C minus plus. So 20C plus D minus plus 2D is 5481. Multiple of 10. So 99 into 10A plus B, this is one of the numbers, plus 2 into 10C plus D is the other number. 5481. 5481 is divisible by 9. So 10C plus D also has to be divisible by 9 at least. 13 minus 5, not divisible by 11. Now, if we start putting values, 99, if we divide 5481 by 99, we will get 54, 50, 45. Checking with 55 into 99, 495, 495, 541, 5445. 2 into 10C plus D. 10C plus D is a two-digit number, so this has to lie between 99 and 2. Maximum, this 198 actually. Maximum value that 10C plus D can take is 98, 99. So 2 into 98 will be equal to 198. And the minimum value 10C plus D can take is 10. So this will be more than equal to 20, less than equal to 198. If we subtract 5481 and we subtract from this 198, we will get the minimum value that it has to have. 5481 minus 198 will be, if we give this 2, we are left with 5483 minus 200, 5283. And if we subtract 21, 5481, then we are left with 20, we are left with 5481, 5461. So 99 into 10A plus B has to lie between 5461 and 5283. Giving a difference about 178. 55. 99 into 54. 99 into 54. 5283, 200. 99 into 53, if we check, it will be less than 5283. 99 into 54 would be 5445 minus 99, therefore 5346. 99 less than this will be 524 something, which is not in this range. 99 into 55 is 5445, which is also in this range. So 10a plus b could be either this or this. Now, if you look at 10c plus d, just erasing some part of the solution. So basically, what we have is either 5346 plus 2 into 10c plus d is 5481. This is even, this will be even, cannot be odd. And therefore 99 into 5355, that is 5445 plus 2 into 10c plus d is the only possibility for a total of 5481. So from here we get 2 into 10c plus d is equal to 5481 minus 5445. 81 minus 45 becomes 36. And therefore 10c plus d would be 18. So the two numbers that we have are AB will be 55, CD will be 18. What is the sum of the two-digit numbers? The sum will come out to 73. Again, I think this question would be a moderate to high level of difficulty question, about 2 to 2.5 minutes to solve it. But again, even at this point, there are two ways of going about the question. What we could have also done was we could have started putting the values of A, because we know that maximum this can take is a value of 99 into 1099. It has to be somewhere less than 900. And therefore, we could have started putting a value of n from there, working with the numbers. But that is something that might take time. So moderate to difficult level of in terms of level of difficulty, attempt time could go up to 2 to 2.5 minutes. Starting with the number 0, all the non-negative integers, non-negative. So you're starting from 0 basically. Are written left to right, one after the other in increasing order. What is the 3888 digit? Okay. Now, if you look at one digit numbers, there are 10 one-digit numbers. You start because you're starting from non-negative, so we start from 0. If you look at two-digit numbers, one-digit numbers, 10 in number, each having one digit, therefore 10 digits will be written. When we write 0, 1, 2, 3, 4, 5 up till 9. If you look at two-digit numbers, there are 92 digit numbers from 10 to 99, each having two digits, therefore 180 digits will be written. When we write 10, 11, 12, 13 and so on till 99, if you look at three-digit numbers, there are 900 three-digit numbers, each having three digits. So 2700 digits will be written. When we write numbers from 100, 101, 102 to 999, if you look at four-digit numbers, there are 9,000 four-digit numbers. So 36,000 digits will be written. If we write numbers from 1000, 1001, 1002 up till 9999. Now, if we have written all of these numbers, what is the total number of digits written? 36000, 2700, 18010. This is 0, 9, 8, 3, 38890. So if we look at all of these numbers from 0, 1, 2, 3 up till 9999, this is the 38,890th digit. We were looking at 38,888th digit. This will be 889, and therefore this will be the 38,888th digit. What will be the 3888 digit? It will be 9 of 9,999, or actually the 900 of 9,999. The answer becomes 9. Again, the process is standard, but at a moderate level of difficulty because the number required is pretty large. The only reason I'm saying that the attempt time should not be very high is because once we look at the total numbers, we realize it is not very difficult to find out because it is one of the last number. It is a digit from one of the last numbers of the four-digit numbers. Therefore, the attempt time may not be high, but conceptually, it's a decent question. Find the number of possible solutions of m factorial is equal to a factorial plus b factorial plus c factorial, where m, a, b, and c are positive integers. What is the maximum value of a factorial plus b factorial plus c factorial? this if A is greater than equal to B is greater than equal to C, maximum value will happen when all the three numbers are equal. So this will be 3A factorial, 3 into A factorial basically, A factorial plus A factorial plus A factorial. Now 3 into A factorial is equal to M factorial. This can only happen when M factorial is such that M is 3 and we have 3 into A minus 1 factorial. In this case, or rather, we have M factorial as M factorial as 3, A minus 1. So if M is A plus 1, sorry, not A minus 1, A plus 1, M factorial can be written as 3 into A factorial. That is the only case when these two factorials will be equal. So the only possibility is that M is equal to 3 and therefore A is equal to 2. So if we have 2 factorial plus 2 factorial plus 2 factorial, that we can write equal to 3 factorial. That is the only solution that is possible. Hence 1 becomes the answer. But again, I'd say it's a very tricky question. Getting it right in the exam may not happen. There is always chance of missing out on a case, and therefore, moderate to difficult level of difficulty, moderate to difficult. Attempt time maybe 2 to 2.5 minutes. What is the last digit of the sum? 0 factorial. 0 factorial ends in 1. 1 factorial ends in 1. 2 factorial ends in 2. 3 factorial is 6. 1, 2, 2, 3. 4 factorial is 24. 5 factorial is 120. Now, since we're looking at the last digit of the sum, we have to realize anything after 4 factorial, that is 5 factorial, 6 factorial, 7 factorial, all of them will end in 0 till 77 factorial. The last digit for all of these terms will be 0. So when we are considering the last digit, these terms do not need to be considered. We are just looking at the first 5 digits. 0 factorial ends in 1, 1 factorial ends in 1, 2 factorial ends in 2, 3 factorial in 6, and 4 factorial in 4. 6 plus 4 is 10, so this goes away. The last digit will simply be 2 plus 1 plus 1, which is 4 becomes my answer. Question 8, answer is 4. Again, easy question. If you have practiced factorial, you would have come across this kind of a question. Not more than maybe a minute and a half to solve this question. What are the last two digits of 9483 raised to power 67483? Since we're looking at the last two digits, we can drop the first two. The last two digits of 9483 will be the same as the last two digits of 83 for any power. Now what we do is we raise the power of 83 by 4 so that we are left with 1 as the last digit. 6483 is not divisible by 4, so we can write this as 83 raised to power 4 and then take out the 3, so we have 80 in the end, becomes divisible by 4. 67480 divided by 4 will be 16870. 64, 16, 3, 4, 8 for the 32, 2, 8, 7 for the 28. So this is 4 into 16870 is 67480 into 83 raised to power 3. Now find out the last two digits of 83 into 4. 83 raised to power 4. So 83 into 83 will end in 3 3s are 9, 8 3 24, 89. And then again 83 into 83 will end in 89. So multiply the two 89s to get the last four digits. 89 into 89. 89 into 89 will be 9 9 is 81, 1 carry forward 8, 9 8 is 64, 8 72, 9 8 is 72, that is 40. 9 8 1 carry forward 8, 9 is 72, 8 is 80, 0. So the last two digits will be 21. The last two digits of 83 raised to power 4 is 21 raised to power 16870 into 83 raised to power 3. We're looking at the last two digits of this. Any number ending in 1 to find the last two digits. We take the tens place of digit of tens place digit multiply of the base multiplied with the unit place digit of the power. 2 into 0 is 0, therefore 0, 1 are the last two digits of 21 raised to power 16870. We'll find the last two digits of 83 raised to power 3. We know that 83 into 83 ends in 89. So we multiply 89 by 83 to get the last two digits of 83 cube. 3 9 are 27, 7 carry forward to 8 3 are 24, 2 6. 8 9s are 72. So 7, 8. The last two digits of this is 87. 87 into 01 will end in 87. Hence, the last two digits of the entire number will be 87. The process for this remains the same. The only problem is the calculation increases a little bit, but in any case, because of that, I'm saying moderate level of difficulty question. In any case, should not take more than 2 to 2.5 minutes. If 24 raised to power k is a factor, so basically 5 factorial, 10 factorial, 15 factorial is divisible by 24 raised to power k. 24 is nothing but 8 into 3 or 2 cube into 3. So this we can say that 5 factorial into 10 factorial into 15 factorial is divisible by 2 raised to power 3k into 3 raised to power k. What is the largest possible value of k is something that we have to find out. We look at the powers of 3 and 2 and 5 factorial, 10 factorial, 15 factorial. 5 factorial has 2 as 2 raised to power 1, 2 and 4. So 2 cube into 3 into whatever is left. So 10 factorial will have power of 2 as 2, 4, 6, 8, 10, 4, 8, 8. So basically 8. So 10 by 2, 5, 5 by 2, 2, 2 by 2, 1. Standard process, 2 raised to power 8. In terms of 3, the power of 3 will be 10 by 3 is 3, 3, 6, 9, and 9 will have another power. So 4. 2 raised to power 8 into 3 raised to power 4 into whatever is left. And then 15 factorial. 15 factorial will have power of 2 as 7 by 2 is 3, 3 by 2 is 1, 11. 2, 4, 6, 8 has 3, 10, 12, 14, 11. So 15 factorial has 2 raised to power 11. For 3, it will be 15 by 3 is 5. 5 by 3 is 1. So therefore 6. 3 raised to power 6. 3, 6, 9, 12, 15. 2 raised to power 11 into 3 raised to power 6 into whatever is left from the numbers, let that be n. And therefore the highest power of 2 is 3, 8 plus 3, 11, and 11, 22. 2 raised to power 3, 2 raised to power 22 into 3 is 1, 4, 5, 3 raised to power 11 into n by 2 raised to power 3k into 3 raised to power k. Clearly, 22 dividing by 3k, the division can happen. So k has to be less than equal to 22 by 3. So that 22 is divisible by 3k. So k has to be less than equal to 7, 1 by 3. Hence the maximum value that k can take is 7. Because clearly the power of 3 is not the limiting power, but the power of 2 cube is the limiting power. So the maximum value that integral value that k can take is 7. Again, the concept is not difficult. It is a repeated concept. But because of the calculation, there are chances of mistakes happening, and therefore I'm saying moderate, but in any case, not more than 2 to 2.5 minutes to solve the question. So if we look at the overall level of this paper, moderate level of difficulty, 6 to 7 questions, 99 correct, 97 plus, 95 plus percentile, 18 to 20 minutes to attempt the paper. What would be my 6 questions? In this test, the 6 questions that I found were to be the easiest were 1, 2, 3, 6, 8, 9. Which are these? Always attempting this direct application of the factorial concept. Similarly here, though there is some calculation involved, but still will get the answer more often than not. This is a direct conversion to base to doing this as well. This I think is a better concept. Everyone will not be comfortable, so I'm not saying this is the easiest of the questions. This was a good question. Finding the solution to the equation might be difficult. So again, not necessarily an exam question. Would have done this because once we start adding the numbers, we realize we're looking at the digit towards the end of the 4-digit numbers. Therefore, I am saying attemptable. This is tricky. Even after solving, you cannot be sure that you got the right answer. This I think should have been done. Repeated question, basic concept, easy calculation, so definitely doable. 9 should have been done because again, once you do two-digit cyclicity, you realize that the process is a repeated process. Just have to take care of the calculations. And again, 10, 12 out of 9 and 10, I'd choose one. I've chosen 9 as the easier one. Might look at 10 as well, whichever you think is you're more comfortable with. Therefore, if I have to choose my six, they would be 1, 2, 3, 6, 8, 9. Some of you might say instead of 9, put the question, choose the question number 10, which is okay in any case. These 6 questions could easily be chosen, and then a question here and there would give you the seventh